Zincox Resources plc has developed the Korean recycling plant designed to treat 200,000 tonnes per annum of electric arc furnace dust and produce about 80,000 tonnes of zinc oxide concentrate, 70,000 tonnes of iron product and generate no waste. The plant is located on the Cheonbuk Industrial Complex near Pohang in southeast Korea.
We're delighted to have developed this state-of-the-art facility, representing as it does a new standard both in environmental protection and in metal recovery. The Korean recycling plant is a clear demonstration of this breakthrough technology, and we intend to roll that out around the world over the next few years.
Zincox is a British company quoted on the AIM market of the London Stock Exchange.
Unlike our peers, most of our shares are held by institutional shareholders who are actually very keen to support our very ambitious development plans.
With a head office in the UK, research and development is carried out from its laboratory and technical office in Belgium.
The company was originally set up to bring to account unconventional zinc ore deposits. But some years ago, we recognised the huge potential of electric arc furnace dust, which is a waste created by the recycling of steel. And over the last 5 years, we've completely shifted the company from mining with a little recycling to 100% recycling, and that's what we're focused on now.
Scrap iron and steel is recycled in electric arc furnaces, which generate a significant tonnage of a hazardous waste dust. Due to the increasingly galvanised nature of scrap, however, this electric arc furnace dust, or EAFD, is also rich in zinc and iron. There are over 6 million tonnes of electric arc furnace dust produced annually around the world, containing over 20% zinc. The dust is either sent to landfill or partly recycled using less efficient technology that's always required a subsidy from the steel industry to be economically viable.
We review all the existing technology, but none were able to provide the breakthrough in cost we needed. The rotary hard furnace showed great promises, but previous attempts failed. We went back to basics and redesigned every aspect of the process through extensive laboratory test work, pilot runs, and computer simulation. The result is the game-changing process we have developed in Korea.
The Iron and Steel Association of Korea carried out a competitive evaluation of technologies to treat electric arc furnace dust. As a result, Zincox was awarded a 10-year exclusive supply contract with the Korean steel mills.
The duration of the contracts is critical because it guarantees feed throughout the period over which the development loans are being repaid. The amount of dust is also important because that guarantees us economies of scale. And those economies of scale allow us to give the mills the best commercial deal. Recognizing that the mills don't want to enter into a contract which is going to create a long-term liability for them, we've created a no-cost package. And then in addition to that, we've provided a price participation to give them some upside in the whole project. Our attitude to this business is to create a long-term, high-quality service to the steel industry, in which both parties benefit. Now we can do this because the breakthrough technology we have really creates a win-win situation.
Industrial land is in short supply and expensive in Korea. However, the Korean government is keen to support projects of national importance and, in addition to special tax privileges, the government purchased the site for Zincox's plant at a cost of $20 million and granted the company a 50-year lease.
The first phase of the development has cost about $110 million and was financed through Zincox's own equity for about $60 million and $50 million which we borrowed from Korea Zinc using a 10-year off-take loan agreement. We made the original decision to make Korea our first project in August of 2010. We then completed a feasibility by October of the same year and we had our groundbreaking in March of 2011. The development schedule for the project was very much a fast track. In Korean they say ballet to keep things moving quickly. About 12 months later then we completed the construction on site according to the original schedule and according to the original budget.
The dust arrives in sealed bulk trailers from all over Korea, is sampled and then assigned to one of 3 silos depending on the grade of zinc contained.
The protection of the environment has been at the forefront of the design of this plant. For example, when the trucks unload, they do so pneumatically, so there's no opportunity for fugitive emissions. This is the floor where we mix the dust, the coal and the binder. So these are the mixing vessels here. And then behind me, on this side, this is where we make the binder. So it comes in dry, we make it up into a liquid-like paste, and then that's added into the mixers. That dust on that slow-moving conveyor is regulating the flow down into this briquetting machine. So as you can see, these are the pockets which work together to create the briquettes. Basically, they're all good quality briquettes or large fragments, all of which are fine in the process. And in fact, there's one final screening before they go into the rotary hearth furnace itself.
The rotary hearth furnace is a circular tunnel with fixed walls and roof, and a rotating floor or hearth. It's built on trestles and effectively acts as a very high-temperature circular conveyor belt. The dried briquettes are evenly fed across the hearth, which carries them around the furnace at a temperature of around 1200 degrees centigrade. While in the furnace, the zinc and other volatile elements are driven off. Near the end of a full rotation, the briquettes encounter a large auger screw that sits just above the hearth and discharges them to a chute at the outer edge.
Before we put the briquettes into the furnace, they look like this. By the time they've gone through the furnace, they come out looking like that. They've lost their zinc, lead and oxygen, and they're about 60% of the former size. In addition to the removal of zinc, when the briquettes go through the process, they also metallize the iron, so it becomes metallic iron. So while the original briquette is barely magnetic, after they've gone through the process, the briquettes are highly magnetic.
To stabilise the iron in these sponge-like briquettes, about 40 of them are taken at 700 degrees centigrade and pushed into larger briquettes that are dense, hard and easy to handle. This is the secondary product from the plant and means there's no waste. On the other side of the furnace to the feeder, there is an outlet through which the gases and fine particles of zinc oxide are drawn off. These off-gases pass through sophisticated heat exchangers to cool the gas and heat fresh air, which is then used in the process. The off-gas is further cooled in a quencher before entering the baghouse, where the main zinc oxide product is recovered.
The baghouse contains 6,000 sock-like filters, which, if put end-to-end, would stretch 15 kilometres. These filters are automatically cleaned, releasing our principal product, zinc oxide concentrate, which is a white powder running about 58% zinc.
The zinc product is conveyed in a sealed system to storage silos ahead of transportation in bulk carriers. For the first phase of development, all the zinc will be sold to Korea Zinc, whose main smelter is located just 60 kilometres away.
This plant will be managed and operated by Koreans, employing 55 employees in phase 1 and 70s in phase 2. This is a really automated and sophisticated plant, so we need well-trained employees. And of course, this will create a lot of other jobs in transport and sport services.
From an environmental point of view, our approach has many benefits. And the most obvious one is the complete elimination of all landfill.
Unlike conventional technology, by producing an iron and a zinc product, the Zincox plant generates no waste. Indeed, it destroys hazardous waste. The toxic elements in the dust, the lead and the cadmium, report to the zinc product. The zinc smelters are used to dealing with these elements, often producing them as valuable byproducts. In addition, a sophisticated water recycling facility ensures there is no effluent discharge from the site.
The plant has been designed with great care and considerable additional cost to ensure that there is no fugitive dust. For example, all our conveyors are sealed units. The air quality around the plant is routinely independently monitored to reassure local stakeholders. Finally, this process is like having a new domestic mine that can contribute to raw material self-sufficiency without any of the waste or disruption caused by mining.
Our short-term objectives are not limited to Korea. We plan to roll this out around the world, and we've already done a lot of work in Thailand, in Turkey and the United States, where we've already identified sites. Our plan is to roll this out in a cookie-cutter way, so it'll be exactly the same size, same engineering, same procurement, and that should allow us a very much more accelerated development of these projects. This is a very exciting time for the company. We have a breakthrough technology and a very strong first mover advantage, which we intend to press home just as quickly as possible. The environmental benefits of our approach are clear to both government agencies and the steel mills, and with their active support, we expect to be able to replicate the Korean plant in other parts of the world over the next few years.